Hello, my name is Sara Pires and I'm a senior scientist at the National Food Institute, and I'll be talking about burden of illness and burden of disease studies. So I'll give you a brief description of why we want to estimate the burden of foodborne diseases. I'll give an overview on burden of illness and burden of disease studies, and then I'll focus more on the latter, burden of disease studies, and we'll end with some conclusions and suggestions for further reading. But let's start with our crucial OneHealth questions. So our ultimate objective within food safety is to prioritize food safety interventions. And for this, we know we need to determine first what is the public health impact of different diseases, foodborne diseases. So how do we decide which disease is more important? How can we rank them and prioritize them? We will then want to know what's causing these diseases, which foods or which animals or risk factors are more important for disease in the population. After doing this, we will want to know what are our options for interventions, and then as a final step, we will want to evaluate the effect of each intervention. But today I will focus on the first question, so studying the impact of different foodborne diseases. And how can we measure this? Well, we can actually, the immediate or obvious answer would be we can look into our surveillance data, the number of cases reported each year of foodborne disease. So this would mean that we will be using incidence as an indicator of importance. For example, in Denmark, it would be pretty straightforward. We can actually go to the website of the Public Health Institute, the Statum Serum Institute, which publishes each year the number of reported cases of disease of the most important foodborne pathogens. But we know now that what's actually captured by surveillance represents only the very tip of the iceberg, whereas the true burden, the reality, the true number of cases in the population remains to a large extent unknown. And why does this happen? If we think of our surveillance system as a pyramid, where we have the number of cases reported on the top of the pyramid and the actual number of cases occurring in the population on the bases, we can explain this gap, this difference, because not everybody that gets ill actually goes to the doctor. Of the people that go to the doctor, not everybody gets a sample taken. Even of the samples that are collected, not all of them are tested at a laboratory. There are issues with test sensitivity, and even all cases that are confirmed, they are not reported. So to actually measure this gap, to try to correct the number of reported cases for underreporting and for underdiagnosis, we use burden of illness studies. These allow us to estimate the true number of cases occurring in the population by estimating multipliers. And I will not go into details on these type of studies on the online lecture. We'll focus more on them on campus. Still, I can tell you that these studies are very useful to inform risk management decisions. And this is because they give us information on the true number of cases, so how many cases occur. They allow us to assess trends over time of foodborne disease, and also to link estimates with costs, healthcare costs, and so do a cost of illness analysis. There are several examples of burden of illness studies conducted worldwide and published. A very famous and large one is the one conducted in the United States by the CDC, Centers of Disease Control and Prevention. And they looked into over 20 pathogens, just to give you an idea of the type of estimates that we can obtain with this type of studies. Here we have two examples, the corrected number of cases of two diseases, salmonellosis and listeriosis. So you can see that, for instance, for salmonella in a given year, from around 42,000 cases that were reported in sentinel sites, then the true estimated number of cases was around 1 million. So we have a very large underdiagnosis and underreporting factor. If we look into listeria, which is a pathogen that causes severe disease, but it's actually seldom in the population, this factor, correction factor, is only around twofold. Other examples of studies conducted worldwide is a similar study in Canada There's also a study in France and in Japan, and then there are others that have been published in scientific literature. So these studies are very useful because they allow us to estimate the true number of cases, but they still leave some questions unanswered. For instance, how can we decide which disease is more important? Would it be a disease that causes 10,000 cases of mild or self-limiting illness due to a given pathogen, pathogen A, or a pathogen that causes, for instance, only 20 cases of disease in a year, but this disease is very severe, causes hospitalization and potentially death? How can we decide what's more important? To illustrate this further, if we look here into the number of cases of different health outcomes by several pathogens, we can see, for instance, that in this given population, this is hypothetical data, but in a given population in a given year, norovirus is causing the highest number of cases. However, if we look into the visits to the general practitioner, to the doctor, which can be seen as a proxy for severity of disease, we can see that rotavirus is causing the highest number, and the same goes for hospitalizations. However, Salmonella is causing the highest number of deaths, which is, of course, the most severe health outcome possible, and also reactive arthritis, which is a sequela that it's chronic and long duration. Campylobacter is causing the highest number of Guillain-Barré syndrome cases, which is also a very severe sequela. And then if we look into irritable bowel syndrome, we have norovirus again causing the highest number. So how can we make sense of these data? How can we decide which disease is more important? For this, we use burden of disease studies, so slightly different terminology here. And these studies allow us to measure the impact of different foodborne diseases, the burden, in a comparable way. So we're able to compare different diseases and risk factors. They do take into account incidence and mortality, but also the severity of the disease, duration, and the wide range of health outcomes, health consequences that a given disease can cause. Because they do build on incidence and mortality, we use data or estimates from burden of illness studies. So they are used, the first type of studies that I mentioned are used as a starting point. And in these type of studies, we typically use health metrics. The most common one is disability adjusted life years, or DALYs. And DALYs are actually conceptually simple. They allow us to measure burden of disease by translating the number of years of life lost due to either premature death or to the loss of quality of life. So if we think of this graph as the life of an individual who was born in a perfect state of life and lives like this for 20 years, when something happens, an injury or a disease, some kind of event that reduces the quality of life of this individual by 40%. And this person lives like this for another 40 years when he or she dies prematurely at the age of 60. So it's prematurely when compared to the life expectancy in the population. So if we sum these 20 years of life lost due to premature death with the 16 years calculated of life due to disability or reduced quality of life, then we have our estimate of DALYs, or burden for this person. And I'm describing here at the individual level, but then of course we will want to run estimates at the population level. And just some basic terminology. We will talk a lot about health outcomes, and these describe all the potential health effects of a given disease, and these can be acute or chronic. And as for disability weights, this is the variable that accounts for the severity of the disease. So it's a factor that ranges from 0 to 1, 1 being the most severe, equivalent to death, and 0 being perfect state of health. And these are estimated based on judgments of people about health losses of different diseases and injuries. Just to give you an example, if we focus on diarrhea, which can be mild, this would have a very low disability weight when compared to severe diarrhea. And because one disease or infection in the case of foodborne pathogens can actually cause a wide range or more than one health consequences, health effect, we will want to define these. We typically use health outcome trees to describe them, and then we link this to the data on the disability weight and duration and incidence of each health outcome, and then we have our total estimate of DALYs. And how can we understand DALY? So what does this mean? What does a high estimate of DALY mean? Well, this would be higher if the disease causes a high number of deaths, especially if these occur in the younger fractions of the population. If it's very severe, so if it has a high disability weight or a high incidence, or also a high number of sequelae, and also if it's long duration. And then, because our ultimate objective is to compare diseases, this is how we actually use our results for burden in the end. So here we're comparing 3 pathogens where we can see immediately that pathogen X causes the highest burden. So it causes the highest number of DALYs in that population. And one advantage within the focus of OneHealth and food safety as well is that it allows us to compare disease, so the burden of disease caused by foodborne pathogens, but also chemicals and other risk factors like nutritional risk factors. And there are some studies that have been conducted in different countries, a much lower number than burden of illness studies. A famous one, and the first one within food safety, was conducted in the Netherlands, and it's actually updated every year. So here you have the results for 2009 as an example, and these groups focus on foodborne pathogens, and you can see that the pathogen or the parasite that's causing the highest burden in the population is Toxoplasma gondii, followed by Campylobacter and others. So this is in the Netherlands. And recently we also have published estimates for burden of disease in Denmark for three foodborne pathogens, Campylobacter, Salmonella, and E. coli VTEC. And you can see that Campylobacter is causing the highest burden among these 3. There's also a very large initiative which is hosted by the World Health Organization, WHO, and it's called Foodborne Disease Epidemiology Reference Group. And this group is looking into the worldwide burden of a wide variety of foodborne diseases, focusing on enteric pathogens, parasites, and chemicals as well. And results from this project will be published within this year. So just to conclude, we will go into more detail on campus. We'll talk about burden of illness and burden of disease studies. Burden of illness studies allow us to estimate the true number of cases in the population, and they're very useful to inform policies and risk management decisions because they tell us the true number of cases, trends, and also allow us to link with health cost data. As for burden of disease studies, they allow us to estimate the true public health impact of disease in a more comparable way because they do take into account incidence and mortality, but also severity and disease, duration, and all sequelae. And they build on burden of illness studies because we need the first step to estimate the true incidence and mortality. So we've been focusing on the first question, on the range of OneHealth questions of our integrated food safety approach. And in the following lectures, you will focus on the following questions, starting with source attribution. So how can we estimate where this burden of disease is coming from, the sources that are causing this burden? And here you have some suggestions for further reading of scientific papers that focus on burden of illness and burden of disease studies.